Hello, today we're going to talk about graphing systems of equations. Alright, so a system of equations. A system of equations is two different equations that have one solution. So, if I have y equals negative x plus 2 and y equals x minus 3. Alright, these are two linear equations that have one solution, usually. Now we're going to talk about in a second consistent, inconsistent, and equivalent. Or no solution, all solutions, or one solution, no solution, or all real numbers. So when I graph this, so I'll graph this one first, here, down one, over one, through, graph this one, up one, over one. Alright, so these are those two lines graphed. Where they cross, so right here, is a solution for them. Alright, graphing is just one way to solve it. There's also elimination, substitution, are the ones we're going to go over. Alright, the first three things we need to know are consistent equations, equivalent equations, and inconsistent equations. So a consistent equation is you have at least one point in common. By point, it means ordered pair. So your xy point. An example of this would be you had x plus y equals 4 and x minus y equals 6. Alright, you can't tell if they have anything. You need to switch them slope-intercept form. When I switch to slope-intercept form, I can see what my slope is. And that's what I need to know if it's consistent or not. Alright, switch this over and I get y equals x minus 6. Alright, so if my slopes are different, alright, I'm going to have a consistent equation. It doesn't matter if their y-intercepts are the same. In this case, if their slopes are different, you're going to have, it's going to be a consistent equation. There's nothing in common here. An equivalent equation is when you have something like y equals alright, you have to switch to the slope-intercept form to see it. So when you switch this, and you switch it by basically solving for the y, you get y equals negative x plus 4. Those are the same two things. So an equivalent equation, all points are the same. Same slope, same y-intercept. Alright, if you have the same slope and the same y-intercept, when you graph it, in this case, you have one line and then the other line would be right over it. Alright, and the last one is inconsistent equation. So an inconsistent equation is they have no common points. Alright, if something has no common points, two different equations, that means the lines are parallel. And if they're parallel, that means they have the same slope. Alright, so if you've ever come across two equations that have the same slope and different y-intercepts, you have an inconsistent equation, none of them will touch. As you can see over here, these have the same slopes and y-intercepts, so they're right on top of each other. This one, you'll have the same exact slope, but different y-intercepts. So if I had x plus y equals 6, and y equals 3 minus x. I solve this, and I get y equals negative x plus 6. Then I just switch that around to slope-intercept form. All right, same slope. My slope here is negative 1, but my y-intercepts are different. That means when I graph these, it'll look something like that. All right, parallel lines. They will never touch. No points in common. All right, now we're going to solve and talk about quadrants. So the quadrants are up here. So the quadrants of a coordinate plane are 1, 2, 3, and 4. So if they ask you which quadrant it's in, you can tell them. So to graph these, they have to be in slope-intercept form. So I'm going to go through the whole process of solving it. I'm going to add 4 to both sides. Subtract x. Y equals negative x plus 4. All right. Now I'm going to graph this one in red. So subtract x. Negative y equals negative x divided by negative 1 divided by negative 1. So whenever you graph something or a linear equation, it has to be in slope-intercept form. You cannot graph if it is not in that form. So both of these are now in slope-intercept form. Now I'm going to graph it. So do it either way you want. I'm going to do it this way. So 1, 2, 3, 4, point, down 1, over 1, graphed. All right, because my slope is negative 1 over 1. And that's my rise over my run. And 4 is my y-intercept. If you need more questions about that, just go to one of the previous videos. I've done a lot of them over graphing. All right, my slope here is 1, so 1 over 1. My y-intercept is 0. So right here, up 1 over 1. There we go. So there we go. I graphed a system of equations. All right. So basically all a system of equations is 2 different equations that I have here. And then when I graph them, they cross at one point. That point right there is your answer. All right, now we're going to graph another one. These are both already in their slope-intercept form, kind of. So when I graph it, if you want, you can make a table. If you want, for your first one, so x is always going to equal negative 5. You can do negative 1, 0, and 1. So negative 5, negative 1, 0, and 1. Whenever you have x equals something, it's always going to be vertical. All right, and then y equals negative 6. I come down here to negative 6. Be the same thing. I'm just going through it a little bit quicker. So your answer for this system of equations, this is graphing, is the point where they cross. So they cross at negative 5, negative 6, right there. That is the only thing that works for both of these. All right, here's another one. So this is already in slope-intercept form. I have to put this in slope-intercept form. So I subtract the x. All right, and now we can graph it. To find the solution, again, there's other ways to find it. So I start at negative 3, rise over run, 1, 2, over 1. Again, if you're having trouble graphing it, go back and watch another video. I graph it quite a bit in other videos. All right. Now we're going to graph that one in red. Starts at positive 3, rise over run, down 1, over 1. And where it crosses is the answer. So it crosses right here, which I already know that's actually 2, 1. 2, 1 is the only thing that'll work for both of these. So if I plug in 2, 1, say that's 1 equals 2 times 2 minus 3. So 4 minus 3 equals 1. Good. So 1 equals 1. Check. That is the answer for that. All right, this has been Graphing System of Equations. Hope it helped.